Question 1 is pretty basic. It's a regular triangle, and you need to find the missing angle, which is C. So we'll begin by reviewing what we know. We already know that the three interior angles of any triangle add to 180 degrees. So we just plug in the two angles we know, 45 degrees, which is A, and 100 degrees, which is B. So then we add them together. 45 plus 100 is 145. So we've simplified the equation so far. And then we subtract 145 from both sides. So we're left with C equals 180 minus 45, which is 35. So we know that the measure of angle C is 35 degrees. Question 2 is a little harder. We're going to start out the same way. We know that the three interior angles of any triangle add to 180 degrees. So A plus B plus C equals 180. So we're going to go through the steps the same way again. Plug in 75 and 61 for angles A and B respectively. Simplify that equation. So we have 136 plus angle C equals 180 degrees. Simplify that. So now we know that angle C is 44 degrees, but we're not done yet, because what we really need to find is angle ACD, which is this angle right here along this outside angle. So we got this far and we found angle C, and we also know that a straight line has 180 degrees. So what we're going to do is we're going to basically subtract angle C from 180 degrees, and that will give us angle ACD. So when we subtract 44, which we found angle C equals 44 degrees, we take 180 minus 44, and that gives us ACD. And when you take 180 minus 44, you get 136. So angle ACD equals 136 degrees. Question 3 is a basic quadrilateral. Again, we're going to start by reviewing what we know. And what we know is that the four interior angles of any quadrilateral add to 360 degrees. So again, just like with question 1, we're going to plug in what we know. And we know that angle A is 83 degrees, angle B is 107 degrees, and angle C is 115 degrees. So we just plug those into the equation, A, B, C, and we know that those plus D equal 360 degrees. So again, we'll simplify that equation, and that simplifies to 305 when you add 83 plus 107 plus 115. That equals 305. So 305 plus D equals 360 degrees, and again, subtract 305 from both sides, and you're left with D equals 55 degrees. Question 4 is a little more complicated, but it's still about quadrilateral angles. So again, we know that the four interior angles of any quadrilateral add to 360 degrees. So we're going to do this the same way. But instead of plugging in just angles, we plug in the whole thing. So R equals 110 degrees. So we plug that in for R. S is 70 degrees. But T is equal to 23x minus 5 degrees. So we plug in 23x minus 5 for T. We plug all of that in. And then U is equal to 14x degrees. So we plug in 14x for U. Because what we're trying to find here is not the measure of a certain angle, but what x is. So R plus S plus T plus U equals 360. So again, we're going to simplify this by combining like terms. So now basically this equation is just written again, but all of the constants are written in purple, and all of the terms with x values in them are written in blue. So now we know that we can combine the purple terms, which are the constants, so 110 plus 70 minus 5, and that gives us 175. And then we combine the blue terms, which the x terms, and we get 23 plus 14, which is 37x. So now we have 175 plus 37x equals 360. So again, we simplify, we subtract 175 from each side, and we're left with 37x equals 185. Then we divide by 37 on each side, and we're left with x equals 5. Number 5 is the most complicated of all. But again, we work through it step by step using what we know, and it's not that bad in the end. So what we have here is a quadrilateral. A, B, D, and C are the points of the quadrilateral. But this quadrilateral is made up of two triangles. So to solve the problem, we're trying to find the measure of angle ACD, which is this angle right here of the quadrilateral. So we can see that angle ACD is made up of this angle and also this angle from the triangle and this angle from this lower triangle. So again, first we're going to try to find angle C of the top triangle. So again, we know that the three angles of any triangle equal 180 degrees. So we plug in what we know, which is 58 from angle A and 74 from angle B. Those are the degrees for those two angles. So again, we solve for C the same way we have on the others. So it doesn't show all the steps here because it's pretty simple. You add 58 and 74 and then subtract that from 180 and you're left with 48. And now we need to find angle C of the lower triangle. Since it's an isosceles triangle, we know that this side and this side are equal, and we also know that this angle and this angle are equal in this lower triangle. And so we also know that angle D right here is a right triangle because of this little box, so we know that that's 90 degrees. So we know that since they're 180 degrees with all three of these sides added together, we know that this is 90 degrees. This angle is 90 degrees. If we take 180 minus 90, we're left with 90. So we know that the angles of these two added together are going to be equal to 90 because this 90 has already been taken out. And since we know that they're even, these two angles, B and C, we can just take 90 divided by 2 because that's what, so we have 90 degrees left, so we'll divide that by 2. So each angle is equal to 45 degrees, both B and C on the bottom. So angle C on the bottom is equal to 45 degrees. So, and here is a little triangle, so what we know now. We filled in the 48 degrees here from the top, and both of these are 45 degrees. So this kind of helps to see what we have to do. We have to take this plus this to get the final angle C, which is what we're looking for. We know that the top angle C is 48 degrees, and we know that the bottom angle C is 45 degrees. So we just add those together to get 95 degrees. So we know that angle C of the quadrilateral is 93 degrees.